Inverses. Okay. When we go from an output of a function back to its input or inputs, we get an inverse relation. Okay. Let's have a look at this. Okay. If we interchange the first and the second coordinates, the x and the y's, okay. So if I interchange -8 with the 5, I'll get 5, -8. Okay. Here's me doing the inverse of the relation. I'm just changing the x and y coordinates. So here it is. Interchanging the first and second coordinates of each ordered pair in a relation produces the inverse relation. Here's an example. Okay, so 2, 4 will produce 4, 2 if I change them around. -1, 3, 3, -1, and so on. If I actually look at this on the graph, so 2, 4 is here, 4, 2 is over here, -1, 3 is here, 3, -1 is here, and so on. Can you see that what it is, and it says down here, it's a reflection across the y equals x line. Okay, a reflection across the y equals x line. This point will go over here, this point comes over here. Okay, so inverse relation. If a relation is divided by an equation, interchanging the variables produces an equation of the inverse. So y equals x squared minus 5x, the inverse relation, x equals y squared minus 5y. Okay, I've just changed the x and the y's around. Okay, and look, if I put some numbers into this, if x equals 5, 5 squared, 25, minus 5 times 5, 25, that'll give me y equals 0. Y squared, okay, if 5 squared, again, can you see it's going to give me x equals 0, okay? So again, interchanging the first and second coordinates of each pair. Thus the graph and its inverse doesn't finish it off, reflection across that y equals x line, okay? It's going to be reflection across the y equals x line is the inverse. Right, okay, let's have a look. Now, this here is a function. Post office, prices of first class stamps. Can you see in 2009, 2010, 2011, the first class stamp was 44 cents. That's okay. Remember, you can have the same answer from different inputs. So same output from different inputs. The classic is the x squared graph. Look, -4 squared is 16 and +4 squared is 16. Different inputs, but same output. Okay. Now if I swap things round, okay, so in other words, if I put all these over here, okay, change the coordinates like I did before, the x and y's, then we go this way, then can you see if this is now the input, this has got 3 different outputs, which is not allowed. This is not a function. So the inverse of this is not a function, okay? Now this here on the right hand side, this is a unique one-to-one function. Can you see? This has unique outputs for every different input, okay? So different outputs from different inputs, not like over here. This is okay, it's a function. You can have the same output from different inputs, but all the output here are different, okay? Now then, if I reverse the direction, then can you see this is okay, it's still a function, okay? So the inverse of a one-to-one is still a function. If it's not, okay, this is not one-to-one, the inverse is not a function. Let's have a look. So a function is one-to-one if different inputs have different outputs. Now what this is saying here is if the inputs are different, then the answers, okay, the outputs are different. Again, going back to this up here, okay? One-to-one, if the outputs are the same, then the inputs must have been the same, okay? Okay, if the answers are the same, then it must have come from the same input. Finally, how do we write the inverse? This is just notation, okay? This is not an exponent, all right? It's just how we write this is the inverse. Now then, function is one-to-one, then its inverse is a function. Again, going back to this, remember? This was not one-to-one, didn't produce an inverse. This was, it did produce an inverse, okay? That was a function. Domain of a one-to-one is the range of its inverse, and the range of the one-to-one is the domain of the inverse, okay? And here's a good example. So let's say that this is the original, this here, okay? Can you see its domain is 0 to infinity, okay? 0 to infinity. We'll look at the range of the inverse, okay? Here's the inverse. Its range, again, the y's is going to be 0 to infinity. So the domain of the original is the range of the inverse. Again, this is the original, its domain 0 to infinity. Here's the inverse, its range. 0 to infinity. The range of the original, okay, this way, negative infinity to positive infinity. The domain of the inverse, negative infinity to positive infinity. And again, last little statement, function that is increasing over its entire domain or decreasing is a one-to-one function. Okay, now remember the x squared is not one-to-one. Again, look at this. Remember this. Okay. Again, that's both increasing and decreasing. Okay, on that graph.